The conservation of angular momentum principle basically states that once you're in the air and are no longer subject to external rotational forces or torques, then your total angular momentum will be conserved until you hit the ground. But how do you generate the angular momentum in the first place? In the case of the turbo flip, a torque is created by the dirt ramp pushing against the bike. Notice that the rider throws his head and shoulders back once he hits the ramp. This puts the rider's center of gravity behind the point of application of the force, creating a backward torque. The torque then acts for the period of time that the bike is in contact with the ramp. The impulse momentum equation states that torque times time equals change in angular momentum. This means the angular momentum of the bike and rider will increase. The bike rider gets all the angular momentum from the ramp during takeoff. Once in the air, that's all he has. If the takeoff was poor, then he hasn't got much angular momentum, and probably not much height either, to work with. If the takeoff is good, then he probably has all the angular momentum he needs. Once in the air, he cannot change the angular momentum, but he can change his moment of inertia. This affects angular velocity or rate of spin. If he wants to spin fast, he tucks tight, a small moment of inertia. If he wants to spin slow, he stretches as tall as possible, a large moment of inertia. In summary, the trick to fast rotation is high angular momentum at takeoff. Rotational velocity can be increased by tucking or decreased by stretching into a layout position.